value of the right become 4 and the value of left become equal to the 1. Now the next step is to delete the any value. I just delete the first value from the right side, that is F, and the second letter, that is a D. So the value of right is decreased by 2, the right become 2 and the left remains same, that is a 1. Now I insert the value at the left end. I insert the value of K, L and M from the right. Now I just insert the value of K, the left becomes 0, initially it was 1, so it becomes 0. Next I insert the value L, as Q is empty, so it goes to the right position. So I take the mode value and it goes to the 4. I take the mode of the 6. Mode 6, the answer is -2. Mode 6 -2 is equal to the 4. The value of left become 4 and the value of right is remain the same, that is 2. Now the first element from the left is deleted. The value of left is 4, so it increment by 1, that is become 5, and the right remain the same, that is 2. Now I just add the value to the left side and add the value from the right side. Add the both value. From the left side I added the S. From after C they insert the S, so the value of right become 3. From the left side I insert the value R, so the value of left become 4. After that this queue is full and there is no other element which I have to insert. The whole DQ is full of the elements. So after that, if I want to insert any element, then it shows me the message of overflow. Now the different types of DQs are the input restricted DQ and the output restricted DQ. So the first now discuss it by one by input restricted DQ. The input restricted DQ allows insertion of element at the one end, that is a rear. I can just insert and delete the element from the rear side, but the deletion on the front side, I just perform the operation, that is a deletion. I perform the deletion from the both hands and I insert the value only from the rear side. This is the input restricted DQ. Here I just insert the value from the rear end, but I can delete the value from rear as well as the front end. The second type of DQ is the output restricted DQ. The output restricted DQ allow the insertion of element at the both ends. I insert the value also from the front side and also from the rear side, but the deletion of the element is only from the front side. I just delete the element from the front side. The operation of deletion only done on the front side. The operation of deletion is not performed on the rear side. These are two types of the DQ here. After that, the next type of the queue, that is a priority queue. A priority queue is a collection of an element such that each element has been assigned a priority, and the order in which elements are deleted and processed comes from the following rules. The priority of the elements are the set, and the elements are deleted according to their priority. The element of the higher priority is processed before any element of the lower priority. Any element which have a higher priority that should be processed first than the lower priority elements. There are the two elements which are of the same priority, then the order in which it comes to the queue, in that order it will be processed. The element have a same priority. At that time we use the FIFO rule, that is a first come first serve order, and in this I just process the element with which come first in the queue. Now the priority queue is again of the two types, that is the ascending priority queue and the descending priority queue. Ascending priority queue, these are the two types of priority queue. In the ascending we use in the increasing order, and in descending I use in the queue in the decreasing order. Now discuss it. Ascending priority queue. And ascending priority queue is a linear data structure. It's a data structure in which element can be inserted, and during removal only the smallest element can be removed. I insert the element in such a order that during the removal of the element only the smallest one be removed. For this I just compare the priority tag given to that rear element. Smallest element I here means the element with the smallest priority. The element which I have to insert in such a order that the elements in the list remain in a order that they have same or a lesser priority in the list. A new element I want to insert should have same or lesser priority. The lowest priority elements is removed from the front end. I want to remove the first element, the first element which have a lowest priority in the list. Now the second is a descending priority queue, and descending priority queue is the same as a ascending priority queue, except the elements with the higher priority except the element with the higher priority remains towards the front. At the front side I have the element with the higher priority, and at the rear side I have the element with the lower priority. If I want to remove any element from the queue, I just remove the element with the highest priority, and during the insertion I followed, in this case the element with the higher priority or the same priority should be inserted. The place where all the element are of the higher priority or of the same priority, at that position I insert my element so that the list remain the same. So for that I have to manage the whole and each and every element of the queue. I have to shift previous element and put that element at that position. Now the next type of the queue is a circular queue, is a form of the queue in which queue is in the circular form. The last element is connected to the first element of the queue. In the linear queue, if I reach to the maximum limit, without checking the front position, the queue shows us the message that it is a full, but it's not the condition, it's not the state of the queue. There are some element, some space are vacant in the side of front, because in the linear queue we not checking the front, we just checking the last element, we can't go back to the front. And that is the limitation of this queue. So overcome that limitation, we use a circular queue. In this the empty space in the queue can be used either in the front side, either or it is on the rear side. We have just to check there is no empty space on the queue, rather we have checking that there is the rear is full with the maximum limit. For this I have to check the condition, that is the front is equal to rear plus 1. That means the value of front is equal to the rear plus 1. The value of front is greater than the rear. At that time we use the we stop the queue, that means the queue is full. Otherwise we can insert the values into the queues. Now the various applications of the queues, the various application where we use these queues. Queue is used in the real world each and every place where a line is to remain, like in a bus stop where the person has to wait, the first person has to out of the line and the last should be enter at the end of the line. That all the real world examples where a line is made, where a queue is made, that is known are the examples of the queues. But in the computer science, in the computer activities, the queue is a major effect. The queue is used in all the system where the FIFO operation, first in first out operation, have to perform. The first here is a time sharing system. In a time sharing system we have to arrange the system in a FIFO, in the line, in a queue. At that the first have to serve, then the next, and then next. In that operation we use the application of a queue. Here I put the system into the queue and they are served one after the another. The second one is the job scheduling. In a normal system where a large number of multi-programming are done, at that case we schedule the jobs in a particular sequence. Before this sequence I use the first in first out sequence. That is a example of, that is a application of a queue. Thread handling, for a program there are large number of threads. We have to process each and every thread. For that I also have to handle each and every thread. Next one is the spooling. In the case of printer or any device where the large number of inputs are there, so I made a queue of that. For that they can process in a particular sequence one after the another. In a printer if there are five different print statements, so it process it up one after the another. The first one is processed, then second, and then third, and so on. These are some of the example of the queue. Rather that the queue is used in each and every place where the FIFO concept is used, that is the first in first out, where I have a concept of the element which first insert should first out, that there I use a queue. Now the main program of a queue, if I want to insert, delete and display the value of the queue, then the main program for that is here the header files has studio.h, conio.h. This is a header file for a program. Now these are the three different functions I use in my program. First one is for the display, that is a void display void. Second one is for to insert the element void enqueue, and third one is to void deque. After that I just globally mentioned the various variables, because these all variables are used by these queues, these are functions. So I just made a global variables. Here int q10, this is a range of q of the 10, then item front is equal to -1, rear is equal to -1, then I int maximum is equal to 9. These are the some of the variables that I have initialize and declare here. After that the main program where I starting my program, here I went to the a variable that is a choice. While want to repeat this program till it's not end, clear screen to clear the screen. Now the message on the screen is printf, with the tab I print q. On the next line I print the first value for the insert of the q, second to the delete of the element, and third is to delete display the elements in the queue, and fourth to exit. Then last one is enter your choice, the choice you want to enter. Now with the scanf operation I enter the choice. With the speech I use a different cases. First one is for insertion, so I use a enqueue operation for that, enqueue function for that, and second one is for deque, I use a deque function for that, for the deletion of any element. Third to display I use a display function, and last to exit the element. Default is a case when we enter the value other than 1, 2, 3 and 4, then it gives our message enter the correct choice. Last is getch to hold the program for a next enter key. Now these functions are enqueue. I have discussed it earlier as enqueue or the or operations, all function that is used to insert the value into the queue. Here if front is equal to the 0 and the rear is equal to the maximum queue, or the front is equal to the rear plus 1, here the condition for the circular queue. If these both of the condition or any of the conditions satisfy, then the queue gives me message overflow, that means queue is full. Either that if there is no condition, both of the condition are not satisfied. After that I check the condition front is less than 0, that means that this is the first element I want to insert into the queue. The value of front and the rear is equal to the 0. With this the value of front and the rear becomes 0. Else if rear equal to maximum value, if the value of rear becomes maximum but the value of front is not 0, at that case I set the value of rear is equal to the 0. Else the last condition, if all the above condition are not satisfied, then I just increment the value of rear with the 1, that is rear is equal to rear plus 1. After that I insert the element, I get the element from the user which want to insert. For this I use a statement scanf %d present item, and that item should put into the queue. Now the next operation is a deque operation, that is deletion of the element from the queue. For this I use if front is equal to the -1, that is a null value or any value less than 0. At that case I print the value underflow. There is no element into the queue that I have to delete, so I print the value underflow. If this is not the condition satisfied, then I check whether the value of front is equal to the rear. The value of front and the rear is equal to, they both have the same value, then I set the value of front and the rear equal to -1. That means this is the last element I have to delete from the queue. After that there is the next condition, that if front is reached to the queue maximum value of the queue, then the value of front becomes the 0. If all of these conditions are not satisfied, then I use the last condition, that is front is equal to front plus 1, that is to increment the value of front by 1. After that the message is show to you, that is a printf element deleted. The element I want to delete is deleted from the screen, and after that there is a getch, that message to display to you. The getch function is used to display the message. Next one is to display. The display is a function to display the value of the queue to the screen. Here I use a printf /n queue elements are to display the value of the queue. For I is equal to the front, then I less than equal to the rear, I plus plus. Here the value of the I starting from the front goes to the rear, and is increment by 1, and after that I print the value of array qi with the example of I. With the example of a queue, I just print that value to the screen. The value of front and rear are also given by the next statement, that is a printf backslash n backslash t, front is equal to %d, rear is equal to %d, front and the rear. The value of front and rear are given to the screen. Last is get ch, and then the program is completed. With these three functions, my program is completed. The output of this program is just like that. First, the screen gives us shows us the queue, and there is a list of the menu that are given to you. You want to insert the element, you want to delete the element, you want to display the element on the screen. Last one to exit from the program. So I just enter, it asks to enter your choice. I enter the first choice, that this I want to insert the element. So it asks to insert the element. I enter 15. Again the same message, the screen become clear, and again I just don't clear it because I want to show you here. But after that the screen clear, and the new screen have again a queue, insert the element, second delete the element, display the element, and exist. Again I enter the first choice, I enter the element 48. With the third option on the right hand side of my, this is a queue, first element, second element, delete the element, third is to display the element, fourth is exit. There is a menu options. I enter the choice 3. Here I want to display the element, so it show me the list of 15 and 48. The value of front is 0 and the value of rear is 2. The two elements are inserted into the queue. After that, with this operation, after that I want to delete the element from the queue. I just press the choice second, so it gives the message element deleted. Just print me the element deleted. After that, again the choices are printed to me. I want to see the queue, whether the elements are deleted or no. So I I give the value here 3. That display the queue elements in the front of me. There is only one element into the queue, so it's display me 48. The value of front is equal to the 1, and the value of rear equal to the 2. The one element deleted, so value of front become 1. Again the next value, it asks me, I enter the 5. That is I just mistakenly I enter the 5, the other option that is not in the queue. So I use the default value here, enter the correct choice. It gives me a message that please enter the correct choice. For this again the program started, and again the list is printed. We can perform these operation number of times till the queue not underflow or is not be overflow. At the last operation, at the last step, I just press the 4. At the 4 is program exit. So this is a program to how to implement a queue, how to implement the various operation into the queue, insertion, deletion, display of the queue. This is the main program. This is a major program. In this operation, a complete program of a queue, I insert the value into the queue, delete the value from the queue, and display the various elements into the queue by using this function. Now the various things I have discussed in this my lecture. Queue is a linear data structure. That means queue is a structure. It's a data structure in which the operation are performed in a particular order. These are some of the points I discussed earlier. I just revive it. Secondly, it's a list of elements in which new elements are added from one end. That end is known as the front. We have discussed it earlier. That is a rear, and removed from the other end. That is called a rear. The element is added at the front end and removed from the second end. That is called a rear end. The queue is also known as a FIFO, that is first in, first out. The element which comes first is the first element to gives out. The various operations that can performed on a queue are the in-queue operation and the deque operation. The in-queue operation is the insertion of the element into the queue, and the deque operation is a deletion of various elements from the queue. There are two different methods to implement the array. First one is an array, and the second one to implement a queue. The first one is an array, second one is a linked list. For the continuous memory location, we use the array. For the non-continuous memory location, we use a linked list. And the three different types of queues are the priority queues, which are all these queues are discussed by us. Second one is a deque, that is a double-ended queue that can insert the value from the both sides, from the rear and the left. Insert and delete the value from both the sides. Second one is a circular queue. It's queue in a circular form is known as a circular queue. The various operation, the various applications of queues are the time sharing system, in the system where we have to produce a value of first in, first out, or the spooling or job scheduling and thread handling. These are some of the applications of the queue that are given by the that are provided by the queue. Thanks. This is all about my lecture. Thank you very much.